Question 35. Propan 1O is oxidized by acidified aqueous potassium permanganate in a similar way to ethanol. Okay, when alcohols are oxidized, they can form aldehydes and then later carboxylic acids. Okay, alcohols, when they are oxidized, they go to aldehydes. These ones you will study them in A level in detail, and then further oxidation takes them to carboxylic acids. Okay, then which compound is produced by oxidation of propan 1O with acidified aqueous potassium permanganate? So since this one is propan 1O, which is CH3 CH2CH2OH, then it will be oxidized to an aldehyde CH3 CH2CHO, then further oxidation takes it to propanoic acid CH2COOH. This is propanoic acid, this is propanal, this is propan 1O. You see? So we look for propanoic acid, which is actually option D. Question 36. The structure formula of methylpropane is this one here. The equation represents the reaction of methylpropane with chlorine. In A level, you will look at the reaction of alkanes. They are unreactive, but with halogens under UV light, there is what we call free radical substitution. The mechanism is free radical substitution. You will learn about that later. But now, in here, we are having, they're telling us to find how many structure isomers with the molecular formula, this one, can be formed from this reaction. Now, this structure here, let me write everything here. This structure is CH3CH. In fact, let me write everything just like this. C. Let me project all of the bonds here. Everything well. Carbon is supposed to have 4 bonds. So there's a hydrogen here, there's a hydrogen here, here, then here, here. There is one here, and then here. Now, when they react with chlorine, because it is a substitution reaction, it can take up the position of any of the hydrogens here, okay? Any of the positions there. So we can have something like CH3, CH, then here there is a CH3, then CH2, Cl. One hydrogen is substituted here, okay, with the chlorine. That is one. Then I can substitute any of the hydrogens there. That means I can have CH3, CH, then here there is CH2, Cl, then there is CH3 here, okay? Any of the hydrogens here can be substituted. So we can have CH2, then Cl, okay? Then there is CH, CH3, then there is also a methyl group here, okay? Then also this one can be substituted, and we have CH3, C, then Cl, CH3, then CH3. These three here actually give the same molecule. It is the same molecule, and its name is the methyl group here. We can see 3. The longest carbon chain is this one here. I can take this one, I can take this one, I can take this one. It's all the same. So I'm going to have this one as 1 chloro. 1 chloro, put a hyphen in between a number and a letter, then methylpropane. I don't need to put the position of the methyl because we don't have 1 methylpropane or 2 methylpropane. It is just that if I put the methyl here, then the carbon chain is going to grow bigger in that case. So we have 1 methyl propane. I mean 1-chloromethylpropane. It is the same thing with this one here. This is now position 1 because the substituent here is going to go to the carbon with the lower number. Okay, so this is 1-chloro, and you can see a methyl here. Okay, propane. And then which other one? You can also see this. Even this one can be 1, then 2, then 3. So methyl here is on the second carbon here. It is the same thing. Okay, but then for this one is 2-chloro. Okay, it is on the second carbon here. Maybe this is the first, second, and then third. Okay, so 2-chloro, then methylpropane. So we are having only 2 isomers, 1-chloromethylpropane and 2-chloromethylpropane. That means our answer has to be B here.